about square roots, which we did a couple random times throughout the school year, but we're going to get into this now the next few days, and how that's going to translate to everything we've been talking about with exponents over the last week as well. So what we're going to do here is kind of merge the two things together. Those square roots that you've done back in, say, middle school, we're going to look at those, merge them with exponents, which you've probably never done before, and then do a little bit more look at that on each day for the next few days. And also at the same time, learn about using some of your calculators as well. So we want to make sure you're using those calculators correctly because we're going to be using some new things with that. Reese?
Do we have to keep bringing our textbooks?
Thank you. I asked you to remind me about that, didn't I? So the question was, do we need to continue bringing our textbooks? So the question to that is no. We are done with our textbooks. Now the only thing I will do with that textbook is we don't need it anymore, but if you like to recycle it, because those are recyclable, you can do one of two things. If you recycle at home, recycle at home. If you don't recycle at home, I will take it and recycle it for you at my house. So if you like to get rid of it here, you can. You can bring it up here at some point and just put it right here on my recycle bin, and I will recycle it at home. Otherwise, take it home, recycle at your house. Just don't throw it in the trash can, because fortunately, we don't recycle here. Okay? That's the only thing I'm asking you to do is bring it back here if you want me to recycle it for you. Okay? That's it. All right, let's get going, guys. On our stuff. That's no problem. Okay, we want to talk some vocabulary here together, guys. Okay, I said square roots, square roots, square roots, square roots. All right, you guys have grown up with square roots, probably. Square root of 25, square root of 36, square root of 100. Those are all nice square roots. Now, we're going to start seeing more tomorrow something besides square roots. Square roots are a specific type of what we call a radical. So a radical is these symbols right here, the radical sign. And those radicals don't have to be just a square root. So we're going to talk about square roots today that you've been growing up with, and then we're going to change these to what we say is a cube root, fourth root, fifth root, sixth root, seventh root, and so on. Now let's talk about each of those different pieces of a radical, because each piece represents something specific, and we're going to talk about that vocab, just like we did with knowing what a base was and knowing what a power was on our exponents, or in our exponential expressions. So here, when I look at this, we read this off as 5 and the cubed root of 27. That's how we read that. So on this one, put your phones away. Close it. Yeah, put it away. 5 and the cubed root of 27. All right. That 5, because it's out front, is what we've been calling that our coefficient. That doesn't change. So here, our 5 is still considered to be our coefficient. Any number that's out front, we call that our coefficient. Now, we have two brand new words out front in math that you probably never heard before. An index and what we call as a radicand. Which one is which? An index and a radicand. Now, the index is what you've been saying probably for a few years. The square root, that square, that is called the index. Which in this case, when I said a cube root a second ago, that cube root, that little bitty 3, that is my index. So when you say a square root of 25, a square root of 100, that square, that means what the index is. That cube root, that 3, that's my index. What's underneath of that radical, that is what we call our radicand. In this case, it is 27. Okay? Knowing the vocabulary is part of the battle. Now, on the next one, all right, what do I have there on the next one? I've got 7, and then that's just my good old traditional square root of 8. Okay? 7 and the square root of 8. Now, the number out front, the big number out front, that's my coefficient. Now, how do I know this is the square root of 8? Because I don't see a number out in front of there. The most common radical that you will work with, that we all work with, that's what you grow up with, is our square root. So technically, there is an index of a 2 always hiding there. Because that is our most common radical out there, our default is just always to just leave it as that without that 2 there. That's just our default as saying that's the square root right there. So sometimes you'll see a 2 there, but most of the time you don't. It's understood that the index is a 2, okay? And then underneath the radical is what we call the radicand, which in this case is 8. So in general terms, what we have then is the big number out front is called our coefficient. Then here we're saying our index is represented as n, and the radicand is x, okay? All right, so let's do this, boys and girls. Y'all should know what the square roots of those are, straight down the line. If you don't know what the square roots are, you got a calculator in front of you, don't you? So, before we just run those through our heads, let's make sure you know how to type those into your calculator correctly. Okay, you got decimals pulled up. You got your graphing calculator pulled up. I know it sounds simple, but can you correctly type in the square root of 1? Y'all should know the answer is 1, okay? But how do you type in the square root of 1 into your calculator? Decimals is pretty straightforward and easy. Square root of 1, all right? Square root symbol is, well, duh, right there. Square root of 1, that's no big deal. Right, graphing calculator people? Okay, graphing calculator people, this is your time to make sure you know how to type things in. Okay, on your keyboard, it's in here on mine on blue. So it's right above the x squared key. And when you want to get into those extra features, you have to hit the second button. And then you hit the x squared, because what we say is these are inverses. So we hit that, square root sign appears, hit 1, and the square root of 1 is 1. Okay? If you don't know how to use your calculator, raise your hand right now. This is the time today to better learn how to use it. Square root of 4, what times itself gives you 4? Square root of 4 is 2. So one more time, make sure you guys know how to type these in, because these are as easy as they get. So Miss Keno's got you right there, Victor. What times itself gives you 9? Square root of 9 is 3. Square root of 16 is, it better be. Square root of 16 is 4. Square root of 25 is 5. Because what is this? It's 5 times 5, right? 4 times 4.
3 times 3, 2 times 2, 1 times 1.
And then we keep going, 6, 7, 8, and we can continue this pattern on forever and ever and ever and ever. Okay? Now, what I'd like you to do then is go to the second column with your calculator. These are not square roots, are they? We're back to exponents. They are fractions. Who cares? Go plug in the next one to your calculator. 1 to the 1/2 power.
Just 1/2.
Yep. Type it into your calculator. So exponent 1, AB button, to the 1/2, and tell me what you get. 1 to the 1/2 is?
Oh.
Now, my graphing calculator people do the same thing. We're trying to figure out what's happening here. 1, how do we get to power? Hit the up arrow. 1 to the 1/2. Hit enter, and what do we get? We get 1. Okay, we're trying to figure out what's going on here. Type in 4 to the 1/2. 4 to the 1/2 is what? Somebody get that yet? 4 to the 1/2 is 2.
And then 3, 4, 5, 6, 7, 8.
So 9 to the 1/2 is, I think Tristan got it already. 16 to the 1/2 is
4.
So Tristan, did you get the pattern?
Yep. 1, 2, 3, 4, 5, 6, 7, 8.
So as you guys kept typing that in, and I go back to my Desmos and I type in 36 AB to the 1/2, and I do that keep same thing. What do you think is happening with these two columns? Are they saying the exact same thing?
Yep.
They are saying the exact same thing.
square root of 1/2 is the exact same thing as saying the other one.
Correct. So as we'll see here in the next couple days, what Tristan said is what we want to look at. That the square root is the same thing as saying it to the 1/2 power. That is our key that we want to keep in our heads, all right? That the square root is the same as 1/2 power. Absolutely, Tristan, what we want to see there. That little bridge that we just saw there, that taking the square root is the same thing as rewriting it to the 1/2 power. That little bridge is what we want to then keep at, okay? So I'm going to modify that, not modify it, I'm going to add into that tomorrow a lot more. These are the nice ones today. So, what we want to now do then is, follow-up question then is, how could we rewrite the following exponential expressions as square roots? So rewrite these as square roots. 81 to the 1/2, I want to rewrite this as, what's it going to look like as a square root?
Just 81 under there.
81 as, now 81, what is that called? The index, the coefficient, or the radicand? It's the radicand. So take a quick second, rewrite these for me as square roots. 100 to the 1/2 power, what's that going to look like? Square root of
100.
100. 121 to the 1/2 power.
Square root of 121.
144 to the 1/2 power.
Square root of 144.
169 to the 1/2 power.
Square root of 169.
196 to the 1/2 power.
Square root of 196.
Now, who cares if it's variables? All right, we're going to get down to 225. But if it's variables, what's the variable going to look like? X to the 1/2.
The square root of x.
Square root of x. The x is now my radicand, right? Keep that same pattern going. Don't overthink things. The square root of x. The square root of y. Okay? Who cares? Who cares? Who cares? All right? Now, think about this, just like we did with exponents, or yeah, the exponents lately. Do you think we can type in the square root of x into our calculator and get some type of nice answer? No. Okay? Can we type in the 225 to the 1/2 power and get a nice answer? All right? So we always like to kind of go through and sometimes check our work. There's nothing really to check here, but I just want to reemphasize to you, if there's just numbers in our problems, we can always check ourselves. But if it's a variable in there, like the next one, x to the 1/2, it ain't going to do anything for you. Okay? All right, so let's flip it. I think you flip it. There's nothing else there, right? So let's flip it. And now what I want you to do is, well, this is not the square root anymore, is it? What's this next one called? These are not the square roots. What are these called?
Third root.
Third root, or we also call it the cube root. That's correct. These are called my third roots, are cube roots. The keyboard,
Yeah.
is it, do you see the keyboard icon at all?
No. I got students logged in.
Oh, students
Just
logged
let
in?
them watch the video.
All right, I'll go over and do that.
So just like we did here, but this is a little bit different. So if you're using Desmos, like really watch, because it's hidden. So we go to where it says functions, and you go all the way down to the very bottom. See this button right here? We're gonna click on that. When that pops up, we can put the 3 there, and then move over and put the 1 there. So like I said, it's hidden really far down in that functions button.
So if you're on Desmos right now, you better go do that because I don't have to repeat myself. You're going to be doing a lot of finding that, what we call that the nth root. That nth root allows you to put anything in there. The most common one is that square root. That's why they put it right there in front of you.
Does anyone not see it in there?
This is right now. Now, did you do the graphing calculator, people?
Oh, I have not done that. I just showed
Okay.
you Desmos
I already
first.
did it.
Graphing calculator, people. Yours is not on your keypad. When you look here on your keypad, all I see is the square root button. That is not the same thing as the cube root, the third root. Okay, what button have we been pushing all school year to get to some more options? Math, that's correct. So we hit math, and here lately we've been working on that very first option of fraction, changing decimals to fractions. But then right below that is option number 4. Now, option 4 is where we're going to be. So we go down to option 4 because it is the third root. And if we type in the third root, and then we can type in the radican.
It's 1, 2, 3, 4, 5 on both.
And cube root of 1 is,
1. Cube root of 8 is 2.
and
4, 5.
we keep typing those in. And the cube root of 8, just to kind of do that one more time there, good practice, helps us out. Cube root of 8 is 2 times 2 times 2, which is 8. And again, if you don't remember that off the top of your head, we can put it into our calculator. The cubed root of the next radican, which is what? 27.
Which is
3 times 3 times 3 is 27. And then 4 times 4 times 4. And then 5 times 5 times 5.
Just wrote down 27.
Why did I do that, Tristan? I don't know. Thank you for calling me out. You said 3, didn't you? Thank you.
And it's the exact same thing.
And it should be the exact same thing. So if we went and just kind of played dumb here, I know it's not a play. Okay, if I typed in, say, 8 to the 1/3 power, we realize, oh, hey, we get a 2 there. And if I did 27 to the 1/3 power, we're realizing that, again, these are turning out to give me the same answers. So they are, again, kind of one and the same thing, okay? So just like I wrote on the other side a second ago, square root of 2 is the same thing as the 1/2 power. The cube root is the same as what? The 1/3 power. And that is my key. I can't emphasize that enough for you to realize that those are one and the same. That's going to carry us into tomorrow. Tomorrow is not probably as straightforward. It's going to be a little funky.
Tomorrow?
Yeah.
Oh,
Tomorrow's only Thursday, Chloe.
Yeah.
Wishful thinking. All right, now let's go ahead and do that. Let's go ahead and rewrite these as what? Exponential expressions as radicals. So let's rewrite these as radicals. Radicals means I want to have that radical sign on there. So 216 to the 3rd power becomes what? Rewrite it with a radical, guys. Don't wait on me. You can rewrite that. Okay? So
And
rewrite
then
it.
add the 3 right next to it.
Rewrite it with a radical sign. Yep. Now, if you write it like that, that's incorrect. Because as Tristan pointed out, this is a 3rd power. So I need to have that index of a 3 out in front. That index of 3 needs to be there. And when I say out in front, this is what, again, I'm meaning for my index. It doesn't come out front as a coefficient. That's not the same thing. The itty bitty 3, like is up above there, that's my index. That means the 3rd power. So 343. Oh, wait, it's not to the 3rd power, is it? What is it? It's to the 1/2 power.
Which is just normal.
So
Just the square root of it.
it's just the square root of it. That is correct. If you put me a little bitty 2 there, is that wrong? No. Do I need to put it there? No. Either one is fine. I'll take either one. But typically, we don't put that there because it's understood that that's the square root. So read carefully of what's there. Hey, 512, we're back to the 3rd power. So I'm looking for the cubed root of 512.
El nombre 3 only the 3 on the bottom.
That's what you want to keep an eye on there, Victor. Who cares? It's a variable. What's it gonna be? Square root or cube root?
What about the 6 and the 5?
What now?
And what about the 6 and the 5?
Six and
It's the
5.
exact same thing as number.
Where do you think it's gonna go?
With the 3, it just goes right to the side.
Look at your pattern that you've been doing there. Okay? Don't overthink that, Victor. On the y, it's going to be a what? Cubed root of y. For the z, do I need to put a 2 there? So we say that's a square root. That was a cubed root. That was a cubed root. That's a square root. So on that 8, what is my index going to be?
4.
We say that's a 4th root. And then, so what's going to be on that 5? Where's that index going to be? It's going to be a 5th root. That's it. That denominator of whatever that denominator is, a 4 becomes the index. 5 becomes the index. Here it's going to be a
6.
That's it. That's it. That's it. That's as easy as it gets. Tomorrow, not as, but you get the basis going right now. Okay. Now let's reverse it all. What do I mean by reverse it all? Change it from what? A radical
To an
exponential form. So now I want to see that written as exponential. Exponential means I want a power on that. So look up above what we just did there, kind of reverse everything. So your radicand of 5 becomes the base. And that index becomes the power. So 5 to the what power? 1 over 4, correct. Look what we just did up above. 1/4. That's it. We're done there. It's as crazy as it gets right now. How about letter B?
X to the 5th.
X to the 1/5. That's correct. That's it. The radicand is acting as the base on the exponent, and the index acts as the power. What's the next one going to look like?
2 to the 1/3.
On the next one.
7 to the 2nd.
Now, I had the 2 there. Again, it's usually not needed. The reason why I put that 2 there is to draw your attention to letter E. What's the letter E going to look like?
6 to this 1. 1/2.
There you go. 1 over 2. Correct. 6 to the half. All right. Because D and E are the exact same thing. Typically, we're not going to see it like that. I can tell you on the quizzes that we're going to have left over, I'm not going to put that 2 there. It's going to look like letter E. Okay.
How many things do that?
At least 1, maybe 2. And lastly, what's that last one going to look like? F is going to become what?
1 to the 2nd.
1 over 2, right? When you say second, it's just 2. 1 over 2, okay? Nothing major, I know what you meant. I'm just making sure you know that. Now, let's bring your vocabulary. When I bring in my vocabulary, let's take that vocab and create what's being described there.
The square root of 5 and also the 3 is right next to it.
Okay, so radicand is 5, that means it's underneath. And the index is 3. That's what it means. There's only one option off of these. Radicand is 5, index is 3. Boom, that's the only answer you can have there. All right, index is 4, radicand is x, coefficient is 5. Bring it all together. Coefficient is where? Out front. Radicand is where? Underneath, and index is itty bitty. Radicand is 7, index is 2, coefficient is 4. Do I need to put that index there? No. All right. Now, it says write a radical expression. I don't give it to you in words, but I give it to you as a exponential. So how am I going to rewrite that from an exponential back to a radical?
This cubed root of 4.
Cube root of x, right?
X, my bad.
Yeah, you're fine. I was just,
4.
I don't know where you got a 4 from there. That's okay though, Tristan. You've been on a roll here. And what's the last one going to look like? Cube root of
512.
512. That's it. If you get this going, you're going to be looking nice to start tomorrow's with. And lastly, Now we're gonna write an exponential based off what I give you. So we got the cube root of 6. Go to an exponential. What's the exponential look like? A base and a power.
Which is 6 to the 1 over 3.
Y to the
1 over 5.
x to the,
1 over 2.
thank you.
Can you zoom it in?
Sure, actually let me do this because I don't need my calculator. There you go, trust me. And then now, here we gotta go 2 steps. Radicand is given to you. Radicand occurs with radicals. So I'm not gonna write my answer just yet. First thing I'm gonna do is say, hey, the radicand is 3 and the index is cubed. So the cube root of 3. Once I know that, oh, now it's pretty easy. So now what do I have? 3 to the 3rd, right? So radicand gives you a radical. Index gives you a radical there. So index of 5, radicand of 4.
So 5 to the 1 over 4. Oh, switched.
And those, so what Tristan just suggested, that's what I'm going to have as multiple choice option. Those are the silly mistakes I know are going to happen. Let's watch those out, okay? And what's about that last one there?
6 and 1 over 2.
All right. So index of 2, radicand of 6, and then he finished on a strong note there, 6 to the 1/2 power. Now I gave you on this day 1, we did all the nice ones that turned out to be getting pretty nice. Tomorrow, if you look at all of this on the back here, what do you notice about all these numerators on our powers? All the numerators are halves, all the numerators are 1. Tomorrow we change that up, that's where things get a little funky. The numerators are no longer 1. They're 3, 4, 5, 6, 7, 8, and so on. That's where things get a little odd. That's tomorrow's job though, okay? All right, so that's where we're gonna pause things. Let me pass out the assignment for you.